Water is the sustenance of life. Without it, nothing on earth could survive. But over the many years of providing quality water to the public, little attention has been paid to the pipes which carry it from producer to end user. With the new worldwide government regulations on drinking water, there's a new awareness of the detrimental effects bad water has on humans, particularly infants and children, due to the high levels of toxic lead and copper coming from water piping and home fixtures. The World Health Organization, following U.S. efforts to curb these high toxic levels, has issued its own recommendation for water producers to lower these contaminants to a point where they're deemed safe for human consumption. In the effort to rectify the metal contamination in the drinking water, various technologies have been developed to help lower corrosion rates in drinking water and thereby, theoretically, lowering both lead and copper levels at the tap. Before we go further, let us begin a tabletop demonstration of Seaquest. As you can see, we have 2 bottles of water, one half filled and one fully filled. We then take some Seaquest made up as a liquid and pour it into our half-filled bottle. We then take a clean, mild steel coupon and place it into the Seaquest treated water, getting the top of the coupon wet so that it will rust in the air vapor. We then place a mild steel coupon into the other bottle as a control. And we now let them sit for a few minutes to see what will happen. The most prevalent and accepted method of corrosion reduction is the Langmuir index theory. This theory is based on 4 elements: alkalinity, total hardness, total dissolved solids, and temperature. By adjusting any or all of these factors, you're able to make water either less corrosive and more scaling, or more corrosive and less scaling. In adjusting these parameters just right, you're able to attain 0 on the index, giving you perfectly non-corrosive, non-scaling water. However, there is one variable in this formulation which is impossible to maintain through the system, and that is temperature. Now, as we all know, the ground temperature is always 65 degrees. So if we calculate our Langmuir index at 65 degrees, then as the water temperature drops in the winter or as the water temperature rises in the summer, the water leaving the water treatment plant will no longer be at 0 at the index and therefore be either corrosive or scaling. When the water arrives at the customer's homes and is being stored in pipes in heated houses or hot homes in the summer, the water will no longer be at 0 on the index and will either be corrosive or scaling. Certainly, all waters, as they pass through a hot water heater, will be out of the index. The problem is that municipalities must choose only one temperature to gauge its index. With the new regulations of lead and copper detection at the tap, this problem has just gotten worse. The municipality wishes to keep corrosion levels at the 65-degree temperature level because that's the temperature where their pipes are in the ground, and obviously they wish to keep corrosion to a minimum there. The homeowner, however, will still be exceeding lead and copper because of the temperature difference by the time the water reaches the tap. Now, as if that was not bad enough, water purveyors are finding that as they raise their pH levels, their chlorine contact time is going down. So they must add in more chlorine to the drinking water, which reacts with the organics found naturally in the water and creating trihalomethanes, THMs, carcinogenic substances whose levels in drinking water have been lowered by EPA from 100 parts per billion ppb down to 80 ppb and shortly down to 40 ppb. This process begins due to the formation of the less stable hydrochloride ion at pH levels above 6.8. Below 6.8, the active chlorine is in the form of the more stable and stronger oxidant hypochlorous acid. Therefore, at any pH levels below 6.8, less chlorine is required to maintain the desired residual at the tap. Above the 6.8 pH level, the stability rapidly decreases because of this formation of the hypochlorite ion, therefore creating the need for higher chlorine usage to maintain the desired residual at the tap. Therefore, we can see that using the Langmuir index as a method of corrosion control is not only expensive, but ineffective, and will have substantial negative effects on drinking water quality. Now we go back to our bottles and see that in the bottle with Seaquest in it, the top of the coupon is corroded, and the bottom section has a protective coating, and the water is clear. On the other coupon, we can begin to see the coupon has some marks of corrosion occurring. We will now flip the bottle with Seaquest over and attempt to remove the rust off of the coupon, and we will see the top section of the coupon, now unprotected by Seaquest, begin to rust. We will let this sit while we go back to our presentation. The one answer in the marketplace today for reduced pitting corrosion levels, actual reduction for metal loss on steel and iron, while reducing leaching corrosion from lead and or copper without the need to increase pH levels in your water system, is Seaquest. Seaquest is a non-toxic blend of inorganic phosphates, manufactured by Aquasmart in Atlanta, Georgia, which provides full corrosion control as a true corrosion inhibitor which functions at all ranges of pH between 5 to 11. Hardness levels and various alkalinities without the need for any secondary technologies or product. Seaquest will also sequester all metals in the water, providing full relief to any and all red water customer complaints, either from iron naturally found in the water or from corroded distribution pipes. Seaquest also sequesters manganese, which eliminates all black water complaints. Because Seaquest is stable to time and temperature, it functions as a sequestrant even in hot water applications such as washing machines and dishwashers. Of course, Seaquest will sequester all hardness found in the water, giving your water the feeling and usage of being soft, an additional customer service which you give to your customers when using Seaquest. Seaquest is totally safe for use in drinking water and is certified for use in drinking water by NSF, the National Sanitation Foundation. Seaquest uses the same phosphates which are found in your everyday diet, in foods such as cookies, cake mixes, meats, seafood, beverages, eggs, jams and jellies, dairy products, fruit and poultry, with one large exception, that the Seaquest usage levels in drinking water is infinitely smaller than in any of these products. So if you have any of the following concerns: elevated lead levels, elevated copper levels, elevated corrosion levels, high pitting formations, high THM levels, red water problems, black water problems, hard water problems, high costs due to pH control products such as lime or caustic, costly cleaning and coating programs, then Seaquest is the one answer for you. Here's how it works. We now can see that the coupon is devoid of any rust on the bottom of the coupon where there was once rust, and the top part of the coupon is now rusted. In our control bottle, we can see that the coupon is rusting and that the water is no longer clear. In the Seaquest treated bottle, where we remove the rust and put it into solution, the water remains crystal clear. Once again, we will flip it over to repeat this Seaquest reaction. These coupons came from the City of Atlanta corrosion coupon test, where Seaquest reduced the corrosion rates from an average of 2.8 mils per year to an average of 1.23. A reduction of 56% in corrosion rates. The control was zinc orthophosphate and pH control of 7.4, and the Seaquest treated coupons were running at a pH of 6.3. As you can clearly see from the first coupon, which came from the non-Seaquest treated side, the entire coupon is covered with heavy tuberculation. We then look at the Seaquest treated coupon to see that there is barely any tuberculation on the coupon. We then send the coupons out to metal samples for them to be cleaned and weighed. As we can clearly see, the non-Seaquest treated coupon is heavily pitted, and the Seaquest treated coupon is totally devoid of any pitting. This shows the strong corrosion control, pitting control that Seaquest has, once again, saving your system the loss of pipes due to pitting. This chart shows the direct effect that Seaquest has over corrosion control when put against pH control at a theoretical 0 on the Langmuir index versus Seaquest on the corrosive side of the Langmuir index. Here, we can watch as we reduce the conductivity of the water by eliminating the lime added into the water on the Seaquest treated side from the desired level of 100 to the low 70s. Then, we see the same happen on the alkalinity, from the desired level of close to 20 to below 10 on Seaquest. By eliminating the lime, the hardness levels dropped from the 40s to the mid-20s. The pH levels dropped from 8.3 to 6.4 to 6.6, whatever the natural pH was after filtration and flocculation. So far, all of this data would point to a more corrosive water leaving the plant. However, as we can see, the total iron and suspended iron on the Seaquest side was 0, where the numbers on the lime side were 0.02 to 0.04, showing corrosion occurring in the pipes. The free chlorine remained constant in both sides, as we would expect, and the turbidity dropped from 0.23 and 0.66 to a low 0.12 and 0.14. This drop is partially from the elimination of lime turbidity and partially from reduced iron corrosion. Again, although we would think that the Seaquest side was more corrosive, we see from the coupons which were installed in the pipes that the Seaquest treated side was less corrosive to both mild steel and gray cast than the pH treated side. The only conclusion to be drawn is that Seaquest without pH control is a better corrosion control product than the raised pH levels. Here we see the loop which the City of Atlanta built to test Seaquest for lead and copper reduction. The Seaquest at the low pH 6.3 without any pre-passivation was able to reduce lead and copper levels quickly and efficiently. Taking just two numbers for comparison on 31092, lead levels were 0.125 and copper levels were 0.784. Just 3 weeks later, on 4/3/92, lead levels were 0.002 and the copper numbers were at non-detect. This reduction is more than anyone could ask for in a corrosion control product. Here, we see an online system who switched from another phosphate product to Seaquest and realized substantial savings and good reduction in their lead and copper numbers. An increase in non-detects from 23 to 32, and where they had 3 numbers exceeding, they now had none. The total 90th percentile reduction was 40%. Again, on the copper, they went from 3 non-detects to 7. Here, we see an online system where DOH of West Virginia allowed Vienna to stop using their caustic and use only Seaquest. As you can clearly see from the charts, they reduced their lead levels and their copper levels substantially and cut their water treatment costs by 80%. Here again we see a system in Maine that was exceeding both lead and copper using caustics, raising their pH to 8.4. They then began using Seaquest and dropped their pH to 7.0. As you can see from the charts, the reduction was substantial, and where they once had 56 out of 80 draws exceeding both lead and copper, after 6 months they were down to only 2 exceeding and were now on reduced monitoring for the lead and copper regulation. Because this is surface water, they also saw a reduction in THM levels and better chlorine residual at the tap while needing less chlorine at the treatment plant. Elimination of red water complaints occurred as well. For AquaSmart, it was one more fully satisfied customer for the Seaquest miracle. Cleanout is another benefit which Seaquest offers to both the municipal user and the homeowner. When used for a period of 6 months to a year, depending on the Seaquest residual in the system, a distribution system can expect 85 to 90% cleanout of their distribution system without any negative effects to water quality. Here we see a typical pipe which has been in distribution for a few years. This is nothing new or different than any other pipes in distribution. It is heavily rusted and tuberculated. We then ran Seaquest through this pipe, and as you can see, the pipe is now clean and devoid of any rust or tuberculation. The benefits of a clean pipe over a tuberculated pipe are obvious, but just to mention a few, you will have better flow rates, cleaner water, and less biofilm formations. The question asked is, where does all the tuberculation go when this cleanout occurs? Well, let me assure you, it does not come out at the tap, or in the showers, or in the washing machines as red water. Now we come back to our bottles to find that the Seaquest has once again cleaned off the rust and has left the water crystal clear, while the control is heavily rusted and the water is very cloudy. When your customers go on vacation and come home to dirty water in their tap, this is the phenomena which you are seeing in the control bottle. The alternative is to offer your customers crystal clear Seaquest treated water as seen in our Seaquest treated bottle. Another way of showing the strong sequestering strength of Seaquest, and again answering the question of where does the rust go, is the following test. As seen here in our tabletop experiment, Seaquest, being the strong sequestrant that it is, keeps all particulate matter in solution and keeps all discolored water clear. Here we take 3 bottles with water and add Seaquest to 1 bottle and shake it into solution. We then add 1 gram of ferrous sulfate, iron, into each of the 3 bottles and shake them into solution. Already you can see that the Seaquest treated bottle is clear, while the other 2 bottles have discolored. We then add 10 drops of sodium hypochlorite, chlorine, to each bottle in an attempt to oxidize the iron and cause it to fall out of the solution. As you can see on the Seaquest treated bottle, the water discolored and is turning back to clear due to the dispersing and sequestering power that Seaquest has. In the other 2 bottles, you can see the discoloration of the water and the actual particulate matter coming out of the solution. We now add Seaquest to one of the heavily discolored bottles in an attempt to disperse and sequester the iron back to clear. As you can see, the Seaquest is actually clearing the discolored water back to clear, which illustrates how the Seaquest is able to keep all waters clear, whether they are discolored due to iron or manganese naturally found in the water, or whether the discoloration comes from the heavy tuberculation in the system. It obviously works the same way on hard water and calcium deposits as it does on iron and manganese. This gives you better flow rates and lower pumping costs. Here we can see a typical installation of Seaquest in a 50-gallon tank, complete with agitator and pump. And here we see large storage tanks for Seaquest, which then feed to day tanks for injection directly into the system at the chlorine contact chamber. As you can clearly see, the multiple advantages of using Seaquest are elimination of costly lime or caustic treatment for raising pH levels, more effective chlorine contact time, lower THM levels, no more red or black water complaints, no more hardness problems, lower lead and copper levels, and all-around cost-effective, top-quality water. We hope that this video has been both educational and enjoyable, and we at AquaSmart look forward to servicing you in the near future.